Okay, so you've seen superheroes lift cars, fly through the sky, and bend steel with their bare hands. But what if I told you real power starts with understanding how the universe actually works? Welcome to the quantum realm. No, not the one in the movies. This one is real, and trust me, it's even weirder and more powerful. I'm here to tell you that quantum physics isn't just for scientists in labs. With the right knowledge, it can be your superpower too. Today's video is based on a beginner's guide, Your Quantum Physics Superpower, by Peter Lee, an amazing book that takes some of the most mind-blowing ideas in science and makes them simple, clear, and fun. If you've ever wondered what reality is made of, or how particles smaller than atoms can change the world, you're in the right place. We're going to break it all down for you. No equations, no headaches, just awesome ideas explained by a bunch of heroes who happen to like wearing capes. Here's what we'll explore together. First, we'll look at the basics of quantum mechanics. Things like wave-particle duality, superposition, and quantum entanglement. Yeah, it sounds intense, but trust me, you'll get it. Then we'll jump into the real-world tech powered by quantum physics, like quantum computing, unbreakable cryptography, and next-level medical imaging. And finally, we'll stretch our minds with some of the deep, philosophical questions quantum physics brings up. Questions about reality, randomness, and how observing the universe might actually change it. So buckle up, heroes. Quantum physics isn't just science. It's a secret weapon. And by the end of this video, you'll see the universe in a whole new way. Let's get quantum.
The history and key figures of quantum physics. To really get quantum physics, it helps to know where it came from, and spoiler alert, it wasn't born fully formed. It grew out of a bunch of smart people trying to explain stuff that classical physics just couldn't handle. The story kicks off in the early 1900s, and it's full of big brains, bold ideas, and a lot of head-scratching moments. It all started when Max Planck was trying to figure out how objects emit heat. Classical physics said energy should be released in a smooth flow, but the math wasn't adding up. So Planck made a wild proposal. What if energy comes in tiny chunks? He called them quanta, and just like that, quantum theory was born, even though he didn't totally realize how big of a deal it would become. Then came Albert Einstein. You probably know him for relativity, but he also played a major role in quantum physics. He used Planck's idea to explain the photoelectric effect, basically how light can knock electrons off metal. To do that, he said light isn't just a wave, it's also made of particles, which we now call photons. This helped confirm the whole wave-particle duality thing we talked about earlier. Next up was Niels Bohr, who came up with a model of the atom where electrons jump between energy levels, kind of like stairs, not ramps. His ideas helped to make sense of atomic behavior and became a foundation for early quantum theory. And then there's Werner Heisenberg, who introduced the uncertainty principle. He said you can't know both a particle's position and speed exactly at the same time. That kind of shattered the idea of a clockwork universe and introduced uncertainty as a core feature of reality. Erwin Schrödinger also made his mark with the famous Schrödinger equation, which describes how quantum systems evolve over time. And of course, his imaginary cat that's both alive and dead until someone looks. These scientists didn't agree on everything. In fact, they argued a lot, but their work built the foundation of modern quantum mechanics. And what started as a few strange ideas turned into one of the most powerful and puzzling theories in all of science. Modern developments. So we've talked about the history, Planck, Einstein, Bohr, Schrödinger, those early pioneers who laid the groundwork for quantum physics. But here's what's wild, the theories they were coming up with over 100 years ago. They're not just sitting in dusty textbooks, they're driving some of the most cutting-edge tech and research happening right now. Back then, these scientists were trying to make sense of atoms and light. They probably didn't imagine that their work would one day lead to quantum computers that can solve problems regular computers couldn't handle in a million years. Yet here we are. Companies like Google and IBM are building real quantum machines based on the same principles those early physicists were arguing about. Schrödinger's equations now help power simulations in chemistry and material science. It's like science fiction becoming a science fact. Quantum entanglement, which Einstein famously didn't like and called spooky, is now a real tool. It's being used to build ultra-secure communication systems, stuff that could eventually make internet hacking nearly impossible. Researchers are working on quantum networks that could totally transform how we share data. Even medical imaging, which started with ideas rooted in quantum behavior, is getting a quantum upgrade. Scientists are developing new imaging techniques that use quantum properties of light to capture details that regular machines can't detect. That could mean earlier diagnosis and better outcomes in healthcare. And it's not just the tech. Quantum physics is influencing how we think about reality itself. Physicists are using quantum theory to explore black holes, the origins of the universe, and even ideas like parallel worlds. It's pushing the boundaries not just of technology but of philosophy and imagination too. So yeah, quantum physics started as a wild theory to explain a few weird experiments, but today it's a driving force in innovation, a foundation for future tech, and still one of the most mind-blowing ways we try to understand the universe. The story that began over a century ago, it's just getting started.
The basics of quantum mechanics. Understand fundamental concepts such as wave-particle duality, quantum entanglement, and superposition. Quantum mechanics sounds intimidating, right? Like something only scientists in lab coats talk about. But at its core, it's just the set of rules that explain how the tiniest pieces of our universe, like atoms and particles, behave. And spoiler, they don't act anything like the stuff we see in everyday life. Let's start with wave-particle duality. Imagine light. You might think of it as a wave, like ripples in a pond, and you'd be right. But light can also act like a particle, called a photon. It's like it can't decide what it wants to be. Sometimes a wave, sometimes a particle. The same goes for electrons. This dual behavior is one of the weird things about quantum mechanics. Particles can behave like waves, and waves can behave like particles. It all depends on how you look at them. Now, let's talk about superposition. This one's fun. In the quantum world, particles don't have to be in just one state. They can be in multiple states at once. Think of it like flipping a coin. In real life, it's either heads or tails. But in the quantum world, while it's flipping, it's kind of both, until someone checks. This idea is at the heart of Schrödinger's cat, where the cat in the box is both alive and dead until you open it. Sounds ridiculous, but it's actually how things work on the quantum scale. Then there's quantum entanglement. This is when two particles get linked in such a way that whatever happens to one instantly affects the other, even if they're far apart. Einstein called it spooky action at a distance because it doesn't make sense under normal physics. It's like they're connected by some invisible thread, and it challenges our basic ideas about space and time. So, yeah, quantum mechanics is strange, but it's also how the universe works at its deepest level. It's behind the tech in your phone, how the sun shines, and even how computers might work in the future. It may be weird, but it's real and kind of amazing once you get into it.
Real-world applications. Learn how quantum principles are behind groundbreaking technologies, like quantum computing, cryptography, and advanced medical imaging. Quantum physics might seem like it only lives in science fiction or complicated textbooks, but believe it or not, it's already changing the real world in some seriously cool ways. The strange rules of the quantum world, like particles being in multiple states at once, or being instantly connected across space, are actually the foundation for some of the most advanced technologies we're developing today. Take quantum computing. Traditional computers, like the one you're probably watching this on, use bits that are either a 0 or a 1. But quantum computers use qubits, which can be both 0 and 1 at the same time, thanks to a principle called superposition. This lets them process way more information at once, which could make them incredibly powerful for solving problems that today's computers can't touch, like simulating molecules to design better medicines, or optimizing huge systems like global supply chains. Then, there's quantum cryptography. Normally, digital communication relies on complex math to keep data secure, but quantum mechanics offers a different kind of security. It uses a principle called quantum entanglement, which means if anyone tries to eavesdrop on a message, they'll actually disturb the system and leave a trace. It's basically unhackable communication. Governments and companies are already investing big into this for the future of cybersecurity. And in the world of medicine, quantum tech is helping us see the body in more detail than ever. MRI machines, those big scanners in hospitals, actually work because of quantum principles. They use the magnetic properties of atoms to create detailed images of organs and tissues. As we understand quantum physics better, we're pushing these machines to be faster, more accurate, and even capable of detecting diseases earlier. So while quantum physics might sound like pure theory, it's not just an academic thing, it's a real-world game-changer. From the way we secure data to how we fight disease and design future tech, quantum mechanics is already shaping the world around us in ways we're just starting to see. Thought-provoking insights. Grasp the philosophical implications of quantum physics and how it challenges our perceptions of reality. Quantum physics doesn't just mess with our understanding of atoms and particles, it messes with our understanding of reality itself. It challenges the way we think the world should work, and honestly, that's what makes it so fascinating. It's not just science, it's almost like science and philosophy colliding. Let's start with one of the biggest mind-benders. The idea that reality doesn't fully exist until we measure it. In quantum mechanics, particles exist in a bunch of possible states at once. But as soon as we observe them, they collapse into one outcome. It's like the universe is keeping its options open until someone takes a look. That raises big questions like, is reality dependent on us watching it? Are we somehow part of how the universe decides what's real? And then there's entanglement. Remember that spooky action at a distance Einstein talked about? When two particles are entangled, whatever happens to one instantly affects the other, even if they're light years apart. That kind of connection seems to break the rules of space and time. It suggests that everything might be way more interconnected than we thought, in a way that goes beyond our everyday logic. Quantum mechanics also brings up the idea that randomness is baked into the fabric of the universe. We like to think that if we just had enough information, we could predict anything. But in the quantum world, some things are truly random. Not just, we don't know yet, random, but it literally could go either way, random. That's a huge shift from classical physics, where everything was predictable and neat. All of this has made a lot of people, scientists, philosophers, and everyday curious folks, wonder what's really going on behind the scenes of the universe. Are we missing a bigger picture? Is our idea of cause and effect too limited? Is there such a thing as objective reality, or is everything kind of fuzzy and uncertain until we interact with it? Quantum physics doesn't give us all the answers, but it definitely makes us ask better questions. And that's where the real magic is. Just before I go, a quick reminder that today's video is based on the great book, A Beginner's Guide, Your Quantum Physics Superpower by Peter Lee. Pick up your copy of the book from Amazon and Google Books. Happy reading, and see you next week.